Like the chi-square test, Fisher's exact test that was introduced in the previous video can only tell us about the strength of evidence of association. It cannot tell us about the strength of association itself. That is, if we have strong evidence of an association, that is a small p-value, it doesn't tell us that the association is big or small. We have to use the same tools that we saw in the chi-square test for describing the strength and direction of the association using things like the difference of proportion and relative risk. So we're going to use the same example that we saw in the previous video, that is the good and bad perceptions based on the wording of a question, to look at this phenomenon. So here we have the contingency table that we developed last time. In this case, we have the wording, that is whether students were asked if they had a bad year or a good year, and the perception that they reported, that is if they had a negative or positive perception. In this case, we saw that students who were asked if they had a bad year replied more negative responses than expected. So they expected, based on our sample size, 4.4 negative responses if students had a bad year. But we observed 8 negative responses in that category. We observed 4 positive responses, which is fewer than the 7.6 expected responses. Similarly, for those who are asked if they had a good year, we observed 15 positive responses, which is more than the 11.4 we expected. So there were more negative bad year responses than expected, and more positive responses in the good year group than expected. We interpreted this Mosaic plot as well. So this is the Mosaic plot that JUMP automatically provides. So to interpret this again, a Mosaic plot gives proportional widths and heights of the bars. So the widths of the bars are proportional to the size of the groups. Here, the good year group is 1.5 times the size of the bad year group. So the good year group is 1.5 times the width of the bad year group. So this is 2/3 of the width of the box, and the bad year group is 1/3 the width of the whole chart. So now we can so we remember from last time our p-value from Fisher's exact test. So Fisher's exact p-value was 0.0086. So that was strong evidence of an association between wording and perception. And because this was an experiment, we had strong evidence that the phrasing causes people to change their perception of the year. But is this a strong association itself? To answer that question, we might want to look at the difference of proportions or the relative risk. And because we've got categorical variables, it's very important to remember what the explanatory variable is and what the response is. We want to compare levels of the explanatory variable. So we're going to compare the probability of a positive response for bad year and a positive response for good year. Or we could compare negative responses for good year versus negative responses for bad year. So we're going to compare group 1, bad year, versus group 2, good year. We can pick any one of the columns of perception, but we're going to compare by groups of the categorical explanatory variable. So for difference of proportions, we're going to do p1 hat minus p2 hat. And if it helps to keep track of this, we can call this p bad minus p hat good. This is going to be, we'll look at this in terms of positive proportions. So this would be 0.33. So the proportion of people who replied that they had a good year when they were in the bad group, a positive perception when they were in the bad year group, minus the proportion of people who had a positive perception when they were in the good year group. So that's 0.833. I have this because I have my row percentages, but we could do this by hand. Of the 12 people in the good year group, 4 reported that they had a positive perception. 4 out of 12 is 33%, or 0.33. The row percentage is what we were looking at. Of the 18 people in the good year group, 15, and let me erase that, 15 said that they were having a positive year. So 15 out of 18 is 83.3%. So again, we're looking at that row percentage. So 0.33 minus 0.833 is negative 0.5. If we wanted to make this positive, we could do p hat good minus p hat bad. But either way, there's a difference of 0.5 or 50 percentage points. To interpret this, the proportion of people in, we should put this in context, I keep doing this wrong, who reported a positive perception in the bad year group that is 0.33 is 50 percentage points lower than those who reported a positive perception in the good year group. So it's a smaller proportion, and this seems like a pretty big difference. Because this is a 50 percentage point difference, even with a small sample, we can say that this is a large effect. But you can also imagine that sometimes scale has something to do with it. So we can also consider the relative risk. Reviewing the video and your notes from the previous time we did relative risk, I'm going to ask you to find P1 hat over P2 hat, and that's going to be the same as P hat B over P hat G. So find this relative risk for a positive perception and interpret it. So P hat 1 over P hat 2, or P hat B over P hat G, is 0.4. That's the same as 33% over 83%. That is, those in the bad year group were what? This is a ratio of proportions. So they were less than half as likely to report a positive perception than those in the good year group. Based on our sample. If we were to collect another sample, these numbers would change, but this tells us for our sample what this would be. Now, I will say that there are ways, we've seen ways of building confidence intervals for differences of proportions, and there are also ways of building confidence intervals for relative risk, but that's beyond the scope of this class. So there is, of course, uncertainty around this relative risk ratio. But this is a nice start. So that's the end of this semester. This is the last video and the end of the content that we're going to cover. I hope that you all have learned a lot. I'm going to miss you. So good luck. Let me know via GroupMe and group discussion boards on ELC if you have any questions. And best of luck.